Hi everyone, welcome to the CloudHired. In this session, we will go through the most frequently asked Kubernetes questions and answers from basics to advanced with YAML example and real-time commentary. If you want this full document, just subscribe and mail me. I will share it to you directly. Let's get started. Why do we need Kubernetes when we have already in Docker? The answer is Kubernetes helps build and run containers, but managing hundreds of containers across the multiple servers manually is the complex. Kubernetes automatic container management, it's an orchestration platform that helps in auto scaling, networking, high availability, reliability, self healing, and storage orchestration. See here, you can understand very clear in Docker. If you want to manage the hundreds of containers, it's very difficult to manage. See, if you want to scale up or scale down or networking for high availability, that's very difficult to manage. So instead of that, Kubernetes came into the picture to manage these all things. See, the main comment is the Docker handle container creation, Kubernetes handle container management and scaling. Scaling means, for example, currently we have running 10 pods in the node. So if you want to scale up 10 to 12, we can scale up, and 10 to 8 also we can scale down. So instead of that, in Kubernetes, that features are not available. So instead of that, only in Kubernetes, very powerful tool for managing these are all auto scaling, networking, high availability. These are all things. Let's go for the second question. What is the namespace in Kubernetes? Namespace provides a logical isolation in Kubernetes cluster. It allows separation of environments such as a dev, QA, and production. Each namespace can have its own research and policies. See here, actually, when you're going to develop application, uh, you need to provide some of the namespaces, right? So, particular, for example, you are developing an application in Terraform. So, if you want to like create a separate environments like QA, production, and dev, we have to provide somewhere the namespaces, right? So instead of that, we need to use the namespaces in Kubernetes. So namespaces helps in multi-tenant environment and support resources quotas. That means, see, multi-tenant environments, environments like dev, QA, and production, something like that only. That helps to do that helps to create the namespaces. What is the difference between pod and container? See here, the pod is a small deployable unit in the Kubernetes. A pod can have one and more container that share and with the same IP address. See here, pod and container will have a same IP address and same volumes, same network namespaces also. Here, see, this allows to use the sidecar patterns like web apps and logging agent. These are all things that will provide. Okay, here, not showing properly. Okay, just we change the color little bit. Uh, Okay, let's go for this color. Okay, and here, how do you distribute the pods and containers to use the limit host resources? Here, if you want to limit uh, if you want to limit the resources, or if you want to restrict pods and containers, here mostly Define a CPU and memory request limits in the pod. This is the YAML file actually. See here, this is the memory, this is the CPU. So if you want to this CPU and memory in container level or pod level, so we can reduce and we can increase this CPU and memory. See here, this is called actually these parameters we have to use like request and limit here. Request and limit and request they're using, right? So based on this only we can reduce the limits. So limits means this is the hard limits they will call. Request means soft limit they will call. And how can you restrict the resources if the engineer forgets to mention them? Okay, by default actually, by default they will give some of the CPU and memory. Uh, if you want to change, we can change. By actually this one, the CPU and memory by default, if you are mentioned or not mentioned, by default they will give. But if you want to change the CPU and memory utilization, you can change here. And how to configure health check in part. Here, health check means use liveness and readiness props. See, for example, after logging to the cluster, uh, see, like kubectl get pods and get nodes. When you're going to type, after running the pods and nodes, it will show the status, right? Like pod is ready and the status is healthy, something like that. So that the information only here. If you write the readiness and liveness, that information only will. It's like a monitoring. The pod is ready or not. How is the status? So based on that liveliness and readiness, it will show liveness and readiness. What is the image pull false in Kubernetes? Here actually image. If you see here, there is three policies actually. If not present, always and never. Okay, based on this policies only. Um, we need to configure in the Kubernetes. The main thing is always in the CI/CD environment to ensure the latest image is deployed. Okay, we need to use always. We need to use the always only. We need to use. How can you provide the environment variable in the pods? So here need to use the config map for externalized configuration. So if you want to use the externalized configuration, we need to use the config map. See here how they are going to attach. Here config maps are decoupling configuration from the container images and providing the portability. See here they mention the duration. So this is the block to attach to the pod. What are the secrets in Kubernetes? Secrets store sensitive information like password, tokens, and keys. See, simply secret means what kind of purpose they will use. Like for example, if you want to store any username and forward, for example, let's say you have the DB like MySQL or Oracle DB. So that contains like passwords and username, some of the tokens, right? So that kind of information if you want to store. So if you want to store based on secrets only, there is a concept called secrets in Kubernetes. So based on that only you have to store. So this is the block for storing secrets. Here the comment secrets are base 64 encoded. Use external secret managers like AWS secrets or secrets manager or vault protection. See, Actually, in the production environment mostly, not only production environment, even dev QA also, secrets are never hard coded. For example, if you want to develop any application by using Terraform, there when you're going to provide the secrets, you have to use the environment variable. So in the secrets and like username and password, you have to go to the AWS console. There is a secret manager. In the secret manager, it will show the key and values. There you can provide the key and values. From there you can call the environment variable. So you always store into the secrets in secret manager or vault also fine. For production, most of production you must follow these are all things. Okay. What is the service in Kubernetes? How many types of services? So how many types exists? Here, service exposes pods to the network and provides stable IP addresses. Types includes like cluster IP, node port, and load balancer. So these are all. If you can integrate like multiple providers like AWS, Azure, GCP, these are all things. So this is the block. This is the block. This is the block you have to follow for the services here. So the complete it's like a networking, incoming and outgoing. Mostly like it's like load balancing means it's like that distribute the traffic, incoming traffic and outgoing traffic. So that will handle. Use load balance for production, grade external traffic routing. Here, what is the replica set Kubernetes? Replica set ensures the specific number of pod replicas are always running. Okay, here, see, replica means, for example, see, in a cluster having nodes, every node contain pods. Every pod contains containers. So, for example, now in the pod in the node having three replicas means three nodes. So if you want to increase 3 to 4 or 4 to 5, here you have to mention replica 3. Currently replica 3 means in the node currently running 3 pods only. See here replica 3 means you can add 3 to 4, 4 to 5. How many, if you want how many you can add. So that's called a replicas. See, ensure high availability, self healing. One if one pod is failed, a replica set recreate it. See here, for example, in the node having three pods or any like more than one pods. If one pod is failed, another pod automatically it will recreate. That's called high availability. That means it never stop. It never stop. For example, in your website suddenly if one pod is fail means it never stop. It will never stop running on website. So if it's automatic create another pod. See here, what is the deployment in Kubernetes? Deployment manages the replica sets and supports zero downtime updates. See, this is the main thing. Zero downtime updates. Replica set. Just now only I explained, right? Replica set. Replica set deployment manage the replica sets and support zero downtime updates. Here, see, for example, replicas pod. For example, one node having 10 pods. In 10 pod, if in case one pod is failed, another pod automatic it will recreate. So instead of that, it will give us 100% like zero downtime updates. It never go downtime. Zero downtime updates it can give. See here, max available to max unavailable to max search to. This means see, for example, when you're going to create a nodes or pods, like minimum maximum we have to mention. For example, minimum if you mention like 2, maximum it will, if you mention like 4, 100% it will run 2. If you, when it's going to scale up until 4, it can run until 4, it can run. That means you need to save the memory to, for example, it will take a lot of loading, right? It will take a lot of, for example, if you put like all nodes are available, that means it will take a lot of loading time. So that means the CPU performance, when if you do like that, means the CPU memory utilization, whenever it can goes down. So if you restrict the particular, if you give the particular like limit, usage like limit, whatever, for example, if you give the minimum and max limit size, it can go very smoothly. What is the daemon set? Daemon set ensure the one pod runs on every node. Use it to task like log collections and monitoring. See, the completed daemon set can handle the nodes and pods only, and also the log collections and monitoring only, uh, that can give. So if you can go through these are all things, you can able to understand like memory, CPU, these are all things. Yeah. So the stateful set here. What is the stateful set? Use it for stateful set application like database where pod identity and storage persistent across restarts. Okay, here see stateful set means here used for stateful applications like databases where pod identity and storage persist across the restarts. See here, mm, for example, whenever your application is going to run, the pods are running, nodes are running. Suddenly, if pod is crossed, if node is crossed, then what will happen? So then only the stateful set what will do, that will create a persistent storage. Persistent storage that will create. For example, okay, the next topic, the PVC and PV and PVC. I will explain this both concept like similar. So here answer is persistent volume and persistent volume claim, physical storage resources and request for the storage. For example, whenever if your pod is down, when your application is crossed, then sometimes we will lost the data, right? So instead of that, we have to create the PV and PVC, persistent volume and persistent volume claim, request for the storage. For example, here if you go to in AWS, there is a EBS volume. Okay, if you go to AWS, sorry, if you go to Azure, there is a blob storage. So we can in here, if you mention those details, so whenever the pod is node is goes down, the data it can save. For example, whenever again, that means we should not lose the data. The that can only the PV and PVC will handle. As well stateful set also will handle. Okay, here what is the ingress and egress controller? Sorry, one is the egress and ingress controller. Okay, here ingress provides easy. This means easy actually. Okay, ingress controller provides the HTTP and HTTPS. For example, routing. See, whenever for example, you have one website, when you hit like www dot, so if you give some host name, that request will coming to the server, right? So that time, that's called ingress. Egress means here is sorry, this is the egress actually. Egress means egress means um, Egress means manage the load balancing and routing. So here this is the external actually. This is the external routing, like how you're going to handle for the incoming requests, outgoing requests also, how you're going to handle. So this based on this only ingress and egress, you'll handle it. Okay. And okay, what are the tails and tolerance? Okay, see, tails are applied on nodes to the repel pods, and tolerance are applied to the pods to allow them to run the taint nodes. Okay, okay. See here, for example, the tails and tolerance. This is a scheduling. For example, when you're going to run the schedule, when you're going to, when we need to run the scheduler, like when we need to run the pods, when we need to run the um, nodes, so we need to schedule. So based on that only, tails and tolerance, that will help you to schedule to run the pods and nodes. Use it to dedicated workloads, security and GPU nodes. Okay. See here, what is the horizontal pod, HPA and VPA? HPA, horizontal pod autoscaler. Horizontal pod autoscaler means that will scale up CPU and memory. See, for example, this is also very important. These are all very important, but this is they must ask this question also. HPA automatically scale the pods based on the CPU and memory metrics. See, for example, earlier I have shown right, like CPU utilization, memory utilization, we can scale up and we can scale down. If you want to increase and decrease, we can change the limits and request, right? So that's the call, that's calling only HP and VPA. So if you want, we can scale up and we can scale down by using this method. They improves performance and reduce the cost of scaling dynamically. Yeah, definitely. See, you have, for example, there is a website called like if you 1 GB, for example, the storage 1 GB storage is enough. Okay, if you provide like 10 GB, it's a waste of utilization, right? So instead of that, when how much you want, that much if you can mention the particular utilization, that we can save the money, right? So that's called only cost by scaling dynamically. Okay, we can reduce the cost by scaling dynamically. Okay, what are the jobs on the cron job? Okay, this is like how to run the cron jobs. These are all things. Okay, how to secure the clusters. Okay, this is also very important. See here, you have to enable the RBAC. RBAC means role based access control. For example, see, in your project, for example, if you are a cloud engineer, if you are an architect engineer, if you are a database engineer, if you are a DevOps engineer, if you are a front end or a back end, whatever the roles available, right? So based on the roles, for example, if you are a developer, you're not required to edit and delete for options, right? So that kind of options. See, role based assessments, based on the role, read and write and delete options we need to provide. So that's called only role based access. Apply the network policies also. Network policy means this particular address only, this particular address only, this particular address only you have to connect. By using this IP address only, you have to connect. So that the based on the IP address only, you have to encrypt the secrets. So yeah, definitely. See, secrets, we have to encrypt. Use the pod security standards and gatekeeper also. Yeah, this is also we have to get. Kaivarna also. See, Kaivarna for complaints also. We have to use. Yeah, yeah. This is the thing only. Yeah, these are all things. You see, this one, when if you are a DevOps engineer, if you are a cloud engineer like AWS or GCP or Azure, or any architect or SRE engineer, when you are going to use the Terraform, Docker, Kubernetes, this one differently. See, whatever I explain here, 80% definitely will give you. 80% they will ask from this document. 80% definitely. If you read this is well, you can and see including example only. I clearly explain. If you want any doubt, definitely you can comment on the section. So I will reply to you. And also if you need this document also, after you can first you can listen this completely end to end, then you can understand. So at least if you understand like 50%, 60% also, I'm sharing this document, then you can read well, then you can easily understand. If you not understand anything, definitely you can give a comment. I am very happy to explain you. I am very happy to help you. And also don't forget to subscribe. Yeah, this is the thing only. That's all for today. Kubernetes interview questions and answers. Like 2025 edition. This is very advanced actually. I hope this helped to you. Subscribe and comment to the section. I will share the complete document if you need. Next we will cover Docker, Kubernetes as well. Sorry, Docker, Terraform, and CI/CD pipeline. These are all things. Thanks for watching CloudHired. Keep learning, keep growing. Thank you very much.